Hello friends, I am Pradeep Yadav. I welcome you all at my channel The Knowledge Adda. Today I am going to discuss a standard way to write assembly language program. I will discuss everything which is required to know you when you are going to start assembly language programming. So, in this video I am going to cover machine code, what is assembly language programming, register in 8085 microprocessor, instructions, first program and how to write a program in a standard way. In this video, I will only discuss overview of register and instruction because this is a part of theory portion. In theory classes, you can know more about instructions and register. So, let me start. What is machine code? Code or language that is written in form of bit or hexadecimal, that is called machine code or machine language. A computer programming language consisting of binary or hexadecimal instruction which a computer can respond to directly is called machine code. Means when we are talking about microprocessor, whatever we are going to do, we will do in form of bits. Actually, if you see my last video, I have already discussed microprocessor take input in form of bits, and that pattern of bits is called machine language, and that machine language microprocessor can understand. Now, 8085 microprocessor uses a total of 246 bit pattern to form its instruction set. Instruction means a command which is given to microprocessor to tell which operation the processor has to perform. Here these 246 bit patterns represent only 74 instruction. Why? Because most of instructions have multiple different format, and you know what happens, sometimes it is very difficult to enter the bit pattern correctly, so they are usually enter into the hexadecimal instead of binary. When we talk about microprocessor, we are going to do everything in form of hexadecimal number, and suppose you have to enter any number, suppose you have write 05, that will consider as hexadecimal in processor. For representing decimal number, you have to write 05D, D means decimal, and if you have write 05H, that will consider as hexadecimal, and you have written 05, that will also consider as hexadecimal number. But when you are going to represent different form of number, then you have to mention as like D. Okay. Now, for example, just I am giving an example. There is an example you can see here is written 0011 and 1100. Meaning of this is increment the content of accumulator. This is very easy to machine to understand what is meaning of that. But for a programmer, for a third person, it is not easy to understand what is meaning of this. Then they converted this bit pattern in hexadecimal. This is hexadecimal of that number. This is somewhat you can say easier compared to this. This is 3C. But when we talk about what is meaning of 3C, means it is still difficult to understand what is meaning of 3CH. Then to remove this type of confusion, this type of difficulty, so each company define a symbolic code for the instructions. These codes are called mnemonics, and the mnemonics for each instruction is usually a group of letters that suggest the operation to be performed. Now, taking same example here, this is 00111100C, means the hexadecimal of this bit pattern is 3C, and this symbolic code of this 3C is INR. Now, if we look at this pattern, 3C is much easier compared to this bit pattern to enter. Now this is much easier to understand. What is meaning of that? If we are talking about INR represent increment, A means register A, or you can say accumulator. The meaning of this is increment the content of accumulator. Now we can say this is much easy compared to this one to understand what we are going to do. So basically this is called symbolic code, sometimes it's called mnemonics, and this is the program written in form of mnemonics, that is called assembly language program. So basically in microprocessor we are going to do program in form of assembly language. Now here INR is a much easier to understand compared to 000 and 3CH. Now just I am taking a second example. Here you can see there is a bit pattern 1 and 7 times 0 that represent 80 in hexadecimal, and that represent in mnemonics, that is add B. Add means addition, B means register B. Means what will do this instruction? This instruction will do add the content of register B with the accumulator and store output in accumulator. So means add B is much easier to understand compared to this bit pattern, and this is part of assembly language. Now it is important to remember that a machine language and its associate assembly language are completely machine dependent. In other words, the code written in a microprocessor is not transferable for others. For example, Motorola has 8-bit microprocessor that is called 6800, or the 8085 machine language is very different from 6800, so the assembly language also will be different. And a program written in 8085 microprocessor cannot be executed on the 6800 and vice versa. Now the language written in form of letter or English like language is called assembly language, which I have already discussed. INR A, add B, basically this is a part of assembly language, because that symbol or that code is written in term of letter or English like language. Now a assembly language implements a symbolic representation of machine code. Your CPU does not execute assembly, the assembler converts into machine code, and this process depends upon both the particular assembly language and the target computer architecture. Now today assembly language is still used for direct hardware manipulation, access to specialized processor instructions, or to address critical performance issues. Typical uses are device drivers, low level embedded system, and real time system. Now the main difference between machine code and assembly language is that machine code is a language consisting of binary that can directly executed by computer, while an assembly language is low level programming language that requires a software called an assembler to convert into machine code. And the symbolic programming of assembly language is easier to understand and saves a lot of time and effort of the programmer. It is easier to correct error and modify program instructions. Assembly language has same efficiency of execution as the machine level language, and this is assembler. Here source code which we are going to provide in assembly language that will convert into machine language, and that machine language will save in memory of microprocessor. Now instruction is just like a command to given to the computer perform a specified operation on a given data. Every instruction has two parts, opcode and operand. Opcode means which operation you are going to perform, operand means which you are going to perform. Just you can take example of INR A. INR means you are going to increment, that is opcode, on which means A is operand. In second example, add B, add addition is that operation you are going to perform, that comes under opcode, and on B that comes under operand. INR, here you can see the now register. There are mainly 8 register, 8 register used in microprocessor to store the data. One is accumulator, flag register, and B, C, D, H, L. And just I am giving overview on this. In my theory classes, you can learn more about this register. Here you can see in bracket there is mention 8, means this register is going to store only 8-bit data. Here SP16 that will store 16-bit data, program counter that will store 16-bit data, and flag register only tells the status after the any operation you perform. The condition and the value of flag register depend upon the content of accumulator after performing the operation. Now, already I have discussed this, and yes, I have discussed. Now, yes, one point I just left. Suppose in 8085 you want to store 16-bit data, then there are 3 possibility of register pair. By making a register pair, we can store only 3 possible register pair. One is BC, DE, HL. BC, DE, HL means B will store 8-bit, C will store 8-bit. Both can store 16-bit data. And when we are talking about register pair, the first content will consider as higher byte, and second content is considered as lower byte. Accumulator is called special purpose register because it store input, also is store output by default, and none operation can be performed without using accumulator. Means for any operation one data should be in accumulator. Now, whenever an operation is performed in microprocessor, the status of flag depends on its output, and it is 8-bit register in which 5 of the bits are used to represent the status, and these are in theory classes I will discuss in detail what is sign flag, zero flag, auxiliary carry, parity flag, and carry flag when they are set, when they are become reset. So I will discuss in theory classes because it will take at least one class to discuss. So, and we have no time, I have to tell you what is standard way to write a program. So just moving towards the program. Now here just we are talking about a program. We have to write a program to add A and B where content of A is 05 and B is 0 phase. So there are some steps you must to follow. First one is load the data in register A, and second data in register B, and A and B store the result and end the program. So how to load? So MVI is an instruction which is used to store the data in a given register. Suppose here I have mentioned MVI A comma 05 means you are going to load 05 in register A. MVI B means you are going to load 05 in B. MVI C means you are going to load data in C. Here second is MVI B. Now add and B. Here I have written add B. Add B means you are going to add A plus B, and this instruction will store the output by default in accumulator. Suppose here written is add C. Add C means A plus C. Add D means A plus D. Add A means A plus A, and by default that will store the output in accumulator here and the program. Same here, add B and C. Oh, sorry, actually I just forget to mention, and I will correct this. Okay. So firstly, load data in B, C, and move a data in register A. Because why? I have already mentioned that without using accumulator you can't perform any operation in microprocessor. One data should be in accumulator, but in this case no data in accumulator. So firstly you have to move a data in A, either B or C. Now add B and C and store result. Now talking about the program, so here MVI B, MVI C. Now move A comma C. This is a standard format. Move is used to copy data from destination to source register. It will copy the data, not move. So don't be confused about this. Means when I written move A comma C means after execution of this instruction the content of C will be 06 and the content of A will be 06 also, because that will going to copy the data, not moving. Okay. Now add b means a plus b. Here you can see data of a is data of c, means indirectly we are going to add b plus c and the result. This is a program. When we are talking about a standard program, then we require three things. One is memory address, mnemonics and remarks. Okay. Now same program, and you can see here this is a standard way to write a program. Here memory address, we are talking about memory address means by default the value of program counted is 0, and when I have written this 2000 means at that time the value of program counter is 2000, and that represent this is a location from where you are going to write your program. So in any time if you require to see data, so by accessing this location we can find data, which type data are stored on this location. Now here is mnemonics. Mnemonics means that instruction which are passing, and here comments. Comments means in which line what you are going to do, and here you can see after 2000 there is 2002 mentioned, because it is totally depend upon instruction size which type of instruction we are using. In theory classes I will tell classification of instruction, where instruction also divided on the basis of length, means 1 byte instruction, 2 byte instruction, 3 byte instruction. In this program only I am telling some easy logic to understand. 1 byte instruction, that instruction only work with register. Here you can see move a comma c, add b and end, because they are working within the register. So these are called 1 byte register. To store this type of instruction we need only one memory location. Here we can see if you are using 8-bit data in any instruction, means that instruction will be 2 byte instruction, and to store those instruction we require 2 memory address. So that's why MVIB 06H 8-bit data is required 2 byte, means 2000 and 2001 reserved for this, same 2002 and 2003 reserved for this. So this is a standard way to write a program. So thank you for watching this video, and also I have mentioned some software simulator tool you can install and you can execute your program, and you can see here I have mentioned a program, so you can see how they work. Thank you for watching this. Thank you.